Logistic regression in R. Logistic regression is a classification algorithm. So it is a function that weighs the input feature or variable so that the output is separated one class to positive values and the other one into the negative values. So in other words, we can say logistic regression predicts a binary outcome, that is either 1 or 0, yes or no, true or false, given a set of independent variables. It is a special case of linear regression when the outcome variable is in categorical value. So logistic regression is also known as generalized linear model, which is the function name used in R, that is GLM. So as you can see in the picture also, we are giving different variables as in the model that we created, and the outcome is either happy or sad. So logistic regression helps us to get to a conclusion or a result where there is either a true or a false value. Some of the examples that can be taken for logistic regression are results of a cricket match. So we generally see a prediction rate on the screen when there is a cricket match, whether the team will win or not. So it is an example of logistic regression. Similarly, if a customer will churn or not after availing a service or buying a product, or another example can be a student selection for a specific course or a college, provided some of the variables or factors. As you can see in today's time, in online courses, people generally take some information regarding students' earlier results and grades and colleges. So it helps in selection rate of that student for that course. So when we build a model, there are different points, we can say elements, that we should understand in order to predict a good model, to create a good model. First is the variables that are required. So we need to understand which variables are helping our model for predicting a better values. We should understand that we should not use a large number of variables, because it will make our model complex. A model will be a better model if we use less variables but significant variables to our model. Next is significance codes. They help us to understand the importance of variables. So as we also discussed in linear regression models, that significance code help us to understand which variables are important for the model, or which variable are affecting the predicting value of that model. Next is the p-value. So p-value is a basic and important factor to understand whether the variable is better for our model or not. So p-value should always be less than 0.05 in order to be kept in that model. And last is AIC. So the archaic information criterion. So it is a estimate of prediction errors. So it helps us to statistically give the quality of the model, whether it is a good model or not. It should be less in the value. Whenever the AIC value is less, it says that the model built is a good model. So as you can see, AIC estimates the quality of each model relative to each of the other models. So when we are creating models, we will not get it at once. We have to create multiple models in order to get to the best model. So AIC helps us to estimate the quality of each model. Lower AIC means model is considered to be closer to the truth. So lower the AIC, it means the value that came out, the result that are coming. Lower AIC means that the prediction that is resulting in from our model is of better quality. To use AIC for model selection, we simply choose the model given over the set of model considered. So AIC models is used to select the model over different models when the value of AIC is less. Next is confusion matrix. So confusion matrix is used in order to summarize the prediction result and get the accuracy of our model. So it is nothing but a tabular representation of actual versus predicted values. It is also known as error matrix. It is the summary of prediction result on a classification problem. The number of correct and incorrect predictions are summarized with the count values and broken down by each value. So as you can see in the image also, so there are total number of observations were 165. So we have built a model and predicted the values. So it is a tabular representation comparing the actual and the predicted results. So the first one, where it is 50 value, so it is actually the result should be no, and our prediction also says no. So there are 50 values which have the same result. There are 10 values where actually it was no and we predicted yes. Similarly, where there is actually there was yes but predicted no, there are 5 values. And if we the actual was no and predicted yes, there were 100 values. So in total, it becomes 165. So it shows a matrix uh, showing summary of our actual and predicted results. Comparison of that. So let's go to R and create a logistic regression model. So first we will read the data. So we are taking the data from the URL. It is available online. So the data is about the selection of students. We are given with the GRE values. So the data shows GRE values, that is graduate record exam score, and GPA, grade point average, and prestige of undergraduate institutions. So how it will affect the admission of a student into a graduate school. So let's check the variables saved in this data. So you can see there are 4 columns, that is 4 variables. First is the admit variable, that whether based upon these factors a student has been selected or not for the graduate school. Next is the GRE value and GPA value and the rank of the institution. How does it affect the admission? We will build a model for that and we'll check the result. So let's check the structure of this data. I am saving this data. I have saved this data in my data variable. And for checking the structure, the command is str. Str will help you to understand the data types and get the observations and variables of that data set. So there are total 400 observations and 4 variables. Admit is an integer value. As you can see, it is the data type of this vector is integer. Similarly, for GRE, it is integer, for GPA, numeric, and for rank, it is integer. And let's also check the summary of this data set. So you can see we are not getting the result properly because if you can check the admit is in 0 and 1 form. It is a binary form. And similarly, rank, it is also a categorical value. So we need to first apply we have to convert them into factors so that we can easily get the data from that. So to convert any of the vector into a factor or a categorical value, the command for that is as.factor. So what we are doing is we are converting the data type into factor, and using $sign we can apply the command to a particular column of the data set. As in this, my data set is my data and I want to convert rank column into factor. So I have executed this command. Similarly for admit also. Now let's check the structure again. So you can see both the columns has been converted into factors. There are 2 levels here, that is 0 and 1. And here there are 4 levels, 1, 2, 3, 4. Now I am checking cross tab. So what does a cross tab? X tab means cross tab. So this command, what does it do is it will tell us which rank is more successful in getting the admissions. So you can see there were four ranks, that are four colleges, 1, 2, 3, 4, and there are the result of the admissions here. So in first college, the students, there were 400 observations, as you can check there. So out of that 420 were not selected in one, 33 got selected in one, 54 got selected in two, 28. So they are the metrics, or you can say tabular representation, to know how the data has been split, the students, whether they got selected in which college or not. So we are creating a logistic regression model. For that, the command is GLM. The model is created in same way we created the regression models, like linear regression, multiple linear regression. So it is the same way. The command name here will be GLM, that is generalized linear model. I am saving my model in my logit variable. Inside the bracket, I am first giving the dependent variable. So we want to understand whether the student got admit or not in the college. So the first, the dependent variable is admit here, and these are the independent factors on which we will get the output. So GRE, GPA, and rank. Now data is my data and family. So you can check the GLM